Okay, so on this circle, the first two things we have already done. It's what you did yesterday, that's our degrees and radians. So I'm going to add those on here first. For my degrees, you can put 0, you can put 360, but you have to put a degree symbol. Then we did our common ones, so 30, 45, 60, and this will be 90. Then we usually jumped down here, which would be 180. And what did we do? We subtract 30, so that's 150. 180 minus 45 is 135. 180 minus 60 is 120. Quadrant 3, we add our reference angle. So 180 plus 30 is 210. 180 plus 45 is 225. 180 plus 60 is 240. 180 plus 90 is 270. In the fourth quadrant, we do 360 minus. So 360 minus 30 is 330. 360 minus 45 is 315. 360 minus 60 is 300. Any questions about getting the degree measures? Okay. And notice I'm trying to do all this without a calculator because that is our goal. On Friday, you're going to have that little 10 questions that I told you. I'm going to tell the sub not to let you use a calculator on that. Okay, so you should be able to evaluate those. Plus, when you have a calculator, some of you tend to write down decimal answers, and I count those wrong anyway. So this will force you to answer me in terms of radicals. So, next step, we are going to put our radians. So 0 degrees, you can call that 0 radians, or if you preferred 0 radians, or what was the other one that we could do? 2 pi. So on the 0, I don't care if you do 0 and 0 or 360 and 2 pi. You just have to have one of them. Then 30 is pi over 6. 45 is pi over 4. 60 is pi over 3. And 90 is pi over 2. My denominator gets smaller as I go up. Okay, we jump down to the 180. 180 is the same as pi. So then, you can go through and convert all these, but we don't need to. We know that the reference angles match up. You know, all of these have the reference angle of 30, so they're all going to end with the same denominator. In the second quadrant, what's the pattern? One less than the bottom. So if this is something pi over 6, it has to be 5 pi over 6. Okay, keeping this idea that my reference angles match up. The next reference angle, all of these are 45s. So they're all going to be over 4. Top is one less, so that would be 3 pi over 4. Okay, next, these all have a reference angle of what? 60. So my denominator for all those will be 3. So one less is 2 pi over 3. All right, in the third quadrant, what's the pattern? One more, because it's bigger than pi now. So denominators still line up, so this would have to be 7 pi over 6. 5 pi over 4. 4 pi over 3. And this would be my 3 pi over 2. Okay, fourth quadrant, what's the pattern? Times 2 minus 1. So this will be over 6, so 6 times 2 minus 1 is 11. So 11 pi over 6. 4 times 2 minus 1 would be 7 pi over 4. 3 times 2 minus 1, 5 pi over 3. So those are the degrees in radians. And again, I highlighted there just to illustrate all of your reference angles match up. They have the same denominators. It's just the numerator that's changing. The next piece we are going to add to this is ordered pairs. Now, for a minute, I want to go back and think about the very first time you learned about trig functions. And we said, what was the definition of sine? Y over r. Cosine was x over r. If I am talking about this circle, we call it the unit circle. A unit circle is a circle with a radius of 1. So, if my radius is 1, y over 1 is just y. X over 1 is just x. So I'm going to add ordered pairs to this. The x is our value of cosine, and the y is our value of sine. I would recommend maybe on the top of your circle or something, giving yourself a little key to help with that. So I'm going to say this is, my ordered pair will be cosine theta, and the y is my theta. And again, this works because the radius of my circle is 1. Okay. Let's go through and start our ordered pairs. This first point, you could think about in terms of cosine and sine of 0. Now, if you use your hand trick, sine is square root of 0 over 2, so 0 cosine radical 4 over 2, which is 1. So the ordered pair is 1, 0. If you think about that picture that we've drawn 1,000 times to evaluate those, haven't we always used 1, 0 for this point? If this is the unit circle and this is your x-axis, you go 1 over and you don't go up or down. So that is the ordered pair 1, 0. I'm going to try to use one color for all my x values and a second for my y's. You can do it however you want. I'm just trying to color code my sine and cosine. As I go up, okay, pi over 6, that's like my 30 degrees. The x is my cosine. What is the cosine of 30 degrees? Radical 3 over 2. Comma, what is the sine of 30 degrees? Radical 1 over 2, which is a half. So at pi over 4, or 45 degrees, what's the value of x, my cosine? Radical 2 over 2. And y, my sine, is radical 2 over 2. Okay, pi over 3, which is 60. X is my cosine, which is 1/2. Y is my sine, which is radical 3 over 2. And at 90, I can use the hand trick. My cosine is 1. My sine is 0. You could just also think about if you plot a point on the y-axis, your x is 0 and your y is 1. So either way, This is the point 0. Okay. Let's talk about this a little bit before we go to the next quadrant. These aren't just made up values, they are the true values of x and y if you were to plot these. So as we notice, as you go around the circle, your x is getting closer to the origin, right? So what's happening to my x values? They're getting smaller. My y starts at 0, but I'm going up, so my y's are getting bigger. Okay, it's just like plotting any other order pair. Now, these are not the only points on this circle. They're the only ones we memorize, but I could pick any point on here. And if I gave you just a random order pair there, the x of that order pair would represent cosine, and the y of that order pair would represent sine. Okay, so these aren't the only points. They're just the only ones we're looking at right now. Okay, let's go to the second quadrant. So, some questions for you. When we are in the second quadrant, what do we use for this order pair? Negative 1, 0. Okay, if you start at 0, 0, you go back 1, so your x is negative 1. You don't move up or down at all, so that's 0. Okay. How are these ordered pairs going to be related to those?
Signs.
Right. When we talk about everything with the reference angle of 30, sine and cosine, they're always the same. The only difference is we have to look at the quadrant to know if they're positive or negative, right? Okay, if you think back any of your algebra days, if you plot an ordered pair over here, what's true about the x? It's negative, and the y is positive. So I don't have to go through and think through all those values again. They are the exact same as these ordered pairs, except the x is now negative. So this one will be negative radical 3 over 2, positive 1/2. Negative radical 2 over 2, positive radical 2 over 2. Negative 1/2, positive radical 3 over 2. So it's not like you have to learn 16 different order pairs. It's the same order pairs over and over again we're seeing. They're all based on the reference angles. So all of these, like yellow angles here, they're all a reference angle of 30. They will have the same order pairs. The only difference is you have to look at what's positive or negative depending on the quadrant. In quadrant 3, what's true? X and y are both negative. So this would be negative radical 3 over 2, negative 1. Negative radical 2 over 2, positive radical 2 over 2. Oh, sorry, negative radical 2 over 2. Negative 1/2, negative radical 3 over 2. What about right here? 0, negative 1. Your x didn't move left or right at all, and your y went down. Okay, question. in the fourth quadrant, what's true? X positive, Y negative. So, positive radical 3 over 2, negative 1/2. Positive radical 2 over 2, negative radical 2 over 2. Positive 1/2. Negative radical 3. That is our complete circle with everything we will ever add to it. This isn't anything we haven't done before. On all those questions, when I've been asking you, what's the sine of 7 pi over 6? We're figuring that out. We just kind of created one picture that has all that information for us. Okay. When I would recommend learning this Friday when I'm not here, if you get done with your homework and you have some extra time, I would draw yourself a circle and practice this. When it comes time to the test, for this test next Thursday, I will ask questions about the circle. I don't know if I'm going to put a complete circle on your test, but if I don't put one on the test, you can ask for a blank one and fill it out if it would help you on the test. Okay. This is just another tool to help us evaluate the things that we've already been doing. So I like to show you several different ways. This is just another way of doing that. Any questions? Okay. The next thing I wanted to show you is actually, again, something we talked about before, but I just wanted to show it to you a different way. Remember when we had the original x, y, and r definitions? And we always found, x squared plus y squared equals r squared. On the circle, my y, or my r, is always 1. So if I took that x squared plus y squared equals r squared, what is x on my unit circle? Cosine. So that means cosine squared theta plus, what's y? Sine squared theta equals 1. Have we seen that before? Remember in chapter 1, I gave you a few identities. There were 3 of them, and I said this is the most important one. It's going to keep popping back up. I just wanted to show it to you another way here. So that one we will continue to use, especially when we get into chapter 5. We will use that one a lot. As far as your formula sheets that I will give you, it is on your formula sheet as one of your identities. So you will have that available. Okay. What I want to do now is just practice answering those questions like sine of 7 pi over 6. So I'll do this in your notes. Keep that unit circle out, but I want you to think through it and then use the circle to check yourself. Don't just look at the circle and then write down the answer. Okay, we're practicing these because I'm going to keep asking you those. We're going to start having those little same question quizzes, asking you to evaluate these things, so we're just practicing today. So I want to find sine, cosine, and tangent for 3 pi over 2. Yeah.
Can you go back for just a second?
Oh, sure. Sorry.
It's okay.
I was just so excited for the next thing. I couldn't help myself. Okay. So without just staring at our circle, let's think through this. 3 pi over 2 is where? Like 270. What is that ordered pair? 0, negative 1. Okay, we have been doing this in terms of x, y, and r, but now I'm telling you, do we really have to do the dividing by r if we know our r is 1? We don't really. We could just look at these ordered pairs. So sine of 3 pi over 2, sine is your y, which is negative 1. Or you could think y over r. Negative 1 over 1 is negative 1. Cosine would be 0. It's just the x value. Okay, so if I've given you ordered pairs that tell you sine and cosine, how are you going to get tangent from that? Okay, y over x. Haven't we also said before that tangent is sine over cosine? Which, ironically, my y is my sine and my x is the cosine. So they're asking you the same thing. So sine divided by cosine, or y over x, you get undefined. If you know sine and cosine, you can answer any of the trig functions by doing reciprocals for secant and cosecant, and for tangent, sine over cosine. All right, let's do sine and cosine of 7 pi over 4. Okay, so I know if you look at 7 pi over 4 on your circle, you've got your x and y, you have sine and cosine. But let's think through it. On a test or quiz, what would I ask you to write down on these questions? Quadrant, reference angle. What quadrant is 7 pi over 4 in? Quadrant 4, because it's double minus 1. Reference angles in radians are easy. It's just pi over 4. Okay. In quadrant 4, is cosine positive or negative? Positive. Pi over 4 is like 45 degrees. What is the cosine of 45? Radical 2 over 2. Okay, in quadrant 4, sine is negative, and the sine of 45 is radical 2 over 2.
Cosine is x. Okay.
Look at your unit circle real quick. Look at 7 pi over 4. Cosine should be the x and sine should be the y. So does this match the ordered pair we put on our circle? Yes. Alright, so on a test or quiz, if you filled out that unit circle first thing, you could use that to check yourself along the way. Why don't you guys take a second and see if you can figure this one out. The negative was, a lot of you messed this up because you looked at that and you said 5 pi over 3, that's quadrant 4. And you were wrong because it's a negative 5 pi over 3. What do we have to do if it is a negative angle? Add 2 pi. Okay. You could use your calculator, or you could think like 2 pi would be like 6 pi over 3. So you get tangent of pi over 3. What quadrant is that? Quadrant 1. So we're just evaluating. Pi over 3 is like what degree measure? 60 degrees. Tangent of 60 is radical 3 over radical 1. which is just radical 3. Okay, if you were trying to get that from your unit circle, look at your pi over 3 on your unit circle. Okay, your x is 1/2 and your y is radical 3 over 2. How would you get this if you're just looking at that ordered pair? Y over x, sine over cosine. You know, if they weren't some that we already knew, you could do radical 3 over 2 divided by 1/2. Flip and multiply. So really today, I'm not teaching you anything new, I'm just giving you another method for figuring out the things we have been doing. Let's do cosine of 2 pi over 3. 2 pi over 3 is in what quadrant? Second, right? The numerator is less than the bottom, so we're smaller than pi. Reference angle is pi over 3. In the second quadrant, cosine is negative. Pi over 3 is like 60. Cosine of 60, 1/2. Look at your circle at 2 pi over 3. Cosine is the x. Was your x negative 1/2 there? So you can use your circle. I just want to practice the calculator problem. So if I want to find the calculator approximation for each of these, if I said cosine of 1.85, that is not one that we just know. So we would have to use our calculator. What should you do first when you turn on your calculator? Check your mode. Is 1.85 degrees or radians? Radians. Okay, just because it doesn't have a pi doesn't mean it's degrees. If it doesn't have a degree symbol, you are in radians. So check your mode, put it in radian mode. And then cosine 1.85 is negative 0.2756. You can only use the calculator on ones where it's not something that I expect you know off the circle. Because if you give me if you gave me a decimal when the answer was like radical 2 over 2, I would count that wrong. So B, cosine of 0.5149. And what do you get? We'll go ahead and do C and D, and then I will probably stop for today. How would I do cotangent? We're not doing the inverse, we're just doing regular tangent, regular cotangent, so all you have to do is 1 divided by the tangent of this. C, for secant, we would do
We doing okay on those? Let's stop here. I have a handout that I'm going to give you.